So today's topic is the string matching problem, and we are going to see that how this problem is going to be solved by using different algorithms. In today's lecture, I will only discuss with one algorithm, which is the naive or the most fundamental algorithm for solving the string matching problem. So basically, string matching is a process of finding a smaller string inside a larger text. So in this problem, we have been given some text or some string, and there is a pattern which is given to us. The problem is that we have to find the pattern inside the text or the string which is given to us. For example, in the searching problem, for example, the word temple is given as a pattern which I need to find out from a given paragraph of text. So this type of problem comes under the string matching problem. The application areas where the string matching is going to be used is, for example, in like text search, the data analysis, and there are many other applications where we can utilize this type of string matching algorithms. When we talk about the different types of string matching algorithms, the algorithm can be designed based on two aspects. The first one, when we are designing an algorithm that exactly matches the pattern with the given data. So these type of algorithms where the pattern and the text is given, and now the pattern is actually going to be matched up on the text, and we are interested in finding out an exact pattern occurrence into the given text or the string. So if this is the case where we want as a result an exact match of the pattern over the text, then the algorithm falls under the category of exact string matching algorithm. The second category is where we are not interested in finding out an exact matching, and there could be different types of factors why we are not interested in finding out an exact match. So if we are not looking for the exact match and we are satisfied with some approximation of matching pattern, then these type of algorithms are called as approximate string matching algorithm. So maybe there could be instances, for example, the exact string matching is going to take up a lot of time. So since we have a lot of or a huge amount of text or the string, okay, and we try to find out the pattern, it is going to take up a lot of time. So if there is a constraint over the time and I want the result within a given constraint of time, then in that case we can have approximate string matching algorithm, right? Or there could be cases where the pattern is not matching over the text, and we are okay in finding out that howsoever the pattern is matching, that much percentage is needs to be reported by the algorithm. So in this case, whether the pattern is completely matching or not matching, right? Even if it is not completely matching, we want the algorithm to report to us that how much the pattern is matching over the text string. So if it is okay if it is not 100% matching, but if it is matching 50% or 60%, then still the algorithm needs to report those results to us. So this is the second case of designing approximate string matching algorithms. Today we are going to discuss about the exact string matching algorithm, which are giving us the presence of the pattern completely into the given text or the string, and if there is no exact match, the algorithm is reporting that the pattern is not found in the given text or the string. So for this problem, we have three different algorithms with us. The first algorithm is the most fundamental and the simplest one, which is called as the naive algorithm. The second algorithm is called as KMP algorithm, the Nath-Morris-Pratt algorithm. and in short it is called as KMP algorithm. The third algorithm is called as the Rabin-Karp algorithm. So for today's lecture, I'm going to discuss the working of naive algorithm. So in naive algorithm, which is the most fundamental and the simplest algorithm, the idea is that, for example, we have been given some text like this, and we are having a pattern, and this pattern needs to be matched up against the text or the given string to find out occurrence of this pattern. How this naive algorithm works here to match up the pattern against the text? So for this, for example, this is the pattern. So I'm writing here the string first. So for example, the given string is like this. Right? And the pattern which I'm going to match against this string is ABCD. Now, the algorithm starts with the first character of the string. So this is my string, right? And this is the pattern. I will take two variables to go through the string as well as through the pattern, right? So I assume that I is the variable that is iterating through the given string or the text, and J is the variable which is going through the pattern. Now, the J's and I, they are going to be initialized with the first character of the string and the pattern. So I we are going to set up to the first character of the string, and J we are going to set up to the first character of your pattern. Now, we are going to compare I and J together. So now I need to compare the character. So for example, if the string is stored in some array denoted as S, I'm going to match up Si equal to Pj, right? So this is the condition that I'm checking up here, right? I'm assuming here that S is the array which consists of the string or the text, and P is the pattern or the array which is stored inside the, which is storing the pattern inside it, right? So I'm going to match up character by character from the string and the pattern. Now, as you can see here, I'm comparing A with A. Since there is a match, we are going to simply increase I as well as J. So in this case, now what I will do, that I will increase I by 1 as well as J by 1. So now J is pointing to B and I is pointing to A. So the next characters that I'm going to compare together is A and B. As we can see that now there is a mismatch. So a mismatch happens, then we backtrack J or we reset J to the initial position. So in this case, now J is going to be set up again to the first character. So J again is pointing to A, and I is also going to be reset to the position where it has started. So I is currently now on the second position, and what happens that in the previous way or in the previous search, what we have done, that we have started I with index number 1. So now I is going to be reverted back to the position 1 greater than the initial position. So initially we started I from here, this location, and now I need to start it or restart it from the second position onwards. Since I is already there, so what I will do, that I will increase I simply. So now in this case, I will be increased up by 1 position. I comes here and J is on the first character, which is A. So now again, I'm matching A and A. Since both of the characters are matching, I is going to be increased up by 1. So I now reaches B, and j is also increased up by 1. So now j reaches here, which is pointing to B. Now we are matching B and B together. Since there is a match, what happens that we are again incrementing I by 1 as well as j by 1. Now we are matching C and C, pointed to by j and I respectively. Again there is a match, so we will simply increase j as well as I by 1 place. And now the characters we are having is A and D. Since there is a mismatch here, A and D, they are not matching, so we again revert back j to the initial position. So now j again comes to index number 1. And I is going to be reverted to which place? So previously, I was started from this position, right? So next time, I is going to be moved up from the third position itself. So we will increase, or sorry, we will revert back I or reset I from this place. So I is now starting from this place. Now again, we follow the same procedure and we match the current character pointed to by I as well as j. If there is a match, we are simply going to increase the pointers or the variables by 1 place, and if there is a mismatch, in that case both I and j, they are going to be reset to some initial position. So this is the whole process, that how this algorithm works. And what is the time complexity of this algorithm? So as we know that how many comparisons the algorithm is making up depends on the length of the pattern as well as of the string. And in this case, the algorithm actually reverts back or resets to the initial position of the string also, as well as of the pattern also. So you can see that I is again coming back to the initial indices, and pattern is represented by j or pointed to by j, and j is again repeating back to the initial characters. So this way the pattern and the string, they are being analyzed in multiple passes, or we can say that multiple passes are going to be applied over the string as well as over the pattern. This leads to the complexity of order of n by m. Now why? So if I assume that the length of the string is, for example, n, and length of the pattern is, for example, m, right? So if I assume that the length of the string or the text is n, I have to take n number of characters, because I am searching here, right? So in the worst scenario, what can happen, that I am going through the whole string, right? So n number of comparisons are going to be done in this case. When I talk about the pattern, the length of pattern is m, and for every character in the pattern, okay, we have to repeat the comparison. Another situation is, in the worst scenario, what could happen, that every character is not matching. So in that case, what you are going to do, you are resetting j to the initial index, as well as you are resetting the I to some initial position, right? So some initial index is going to be assigned to I also whenever there is a mismatch. So how many mismatches could be possible? There could be, for example, m mismatches, and for every mismatch you are again scanning whole of the string one by one again. So that way the complexity of this algorithm comes to order of n cross m, right? Now the problem with this naive algorithm, and another question is that how we can optimize the time complexity of naive algorithm. So the problem with time complexity here is that we are making multiple passes over the string. And in the string matching problem, for example, if you all know that there is a functionality in Word, for example, where we try to search for some word into some paragraph or the document, right? The pattern usually is having lesser length as compared to the length of the string or the text. Okay, so the length of the string or the text is actually much larger as compared to the length of the pattern. So no matter how many repetitions I am taking up for the pattern, that is not increasing the time complexity too much. But if I am taking multiple passes over the string or the given text, since the length of this string or the text could be a large number of characters, so those passes or those number of comparisons are actually going to increase the time complexity of the algorithm. So this is one of the problem with the naive algorithm, and that way the time complexity comes to n cross m. Now, how we can improve this time complexity of naive algorithm? So we already have identified the reason that why the algorithm or why naive algorithm is taking up so much time. And the problem is that it is taking multiple passes over the given string or the text. So if we are able to reduce the number of passes over the string or the text, then the time complexity could be improved in some way. So the next algorithm, which is the KMP algorithm or the Nath-Morris-Pratt algorithm, takes advantage of this fact, and it actually tries to remove multiple passes over the string or the text, and that way the time complexity comes down to n plus m. So the time complexity of KMP algorithm comes to order of n plus m, and this is because of the fact that this algorithm or the KMP algorithm is not taking up multiple passes over the given string or the text. So this is all for today. Thank you. In the next lecture, we will see that how KMP algorithm works, and then after that we will analyze the time complexity of KMP algorithm and why it is performing better as compared to the naive algorithm. So thank you very much.